The objective of this lesson is to use the understanding of volume to find the dimensions of a rectangular prism. This lesson is a task-based lesson, and the main purpose is for students to apply the mathematics they know to solve a real-world situation. Allowing students to struggle productively is important. Let's begin with the task. Your team is responsible for designing a cereal box to meet a specific set of criteria. The volume of the box must be 225 cubic inches. The length of the box must be 7 1/2 inches. Determine the height and the width of your box. Create a scaled net of the box using grid paper. Use the net to calculate how much cardboard is needed to create each box, assuming there are no overlaps. Most cereal boxes are rectangular prisms. Volume of a rectangular prism is found by multiplying the length times the width times the height. The volume and length are known, so let's put 225 cubic inches for the volume and 7 1/2 inches for the length. Divide by 7 1/2 to isolate the width and height. The equation now reads 30 equals width times height. The width and height multiplied must equal 30. Let's try the width as 2 inches and the height as 15 inches. 2 times 15 equals 30. Now let's use these measurements in the formula for volume. 7 1/2 times 2 times 15 equals 225 cubic inches. It works. Let's create one more set of dimensions. Let's try the width as 3 inches and the height as 10 inches. 7 1/2 times 3 times 10 equals 225 cubic inches. These dimensions also work. Students will have a variety of answers. Just make sure that the volume is 225 cubic inches and the length is 7 1/2 inches. Let's use the second set of dimensions to create the box of cereal. The next step is to draw a scaled net of the box on grid paper where each box represents 1 inch. Let's start by drawing the front of the box. The dimensions will be 7 1/2 inches across by 10 inches high. This will be 7 1/2 squares across and 10 squares up on the grid paper. The next face is the bottom of the box. The length is still 7 1/2 inches and the width is 3 inches. Draw down 3 squares and across 7 1/2 squares on the grid paper to make another rectangle. The next face is the back of the box, which is the same dimensions as the front. Then the top of the box has the same dimensions as the bottom. The last two faces to draw are the sides of the box. The dimensions are 10 inches in height by 3 inches in width. This is shown by starting along the side of the front face and going out 3 squares and down 10 squares to create a rectangle. Do this again on the other side. The next part of the task is to calculate how much cardboard will be needed to make the box. This is done by calculating the area of each face and then adding them together, which is also known as the total surface area. The front of the box has the dimensions of 10 by 7 1/2. 10 times 7 1/2 equals 75 square inches. The next face is the bottom of the box. 7 1/2 times 3 is 22 5/10 square inches. The next face is the back, which has the same area as the front, which is 75 square inches, and the top has the same area as the bottom, which is 22 5/10 square inches. The last two faces are the sides, and they also have the same area of 10 times 3, which is 30 square inches. In order to find the total surface area, add all the areas together, equals 255 square inches. Another way to calculate the surface area would be to count each square in the net. Although this can be correct, it is much more efficient to use the previous method by calculating the area of each face of the net. Students will then move on to creating a design for the cereal box to meet specific requirements. The objective for this lesson was to use the understanding of volume to find the dimensions of a rectangular prism. We met this objective by creating a variety of boxes with the same volume and the same length, but different heights and widths. We then created a net of the box and calculated the surface area.